Have you ever wondered if life could exist on Mars? Our fascination with the red planet has propelled numerous missions through the decades, each contributing to our understanding of this enigmatic world. The tantalizing question of life, past or present on Mars, has echoed through the ages. The search for evidence of life continues to inspire scientists, igniting our collective curiosity. But how do we transform this barren world into a livable habitat? To answer this, we need to dive deep into the process of terraforming. Terraforming, a term coined by science fiction, is now a scientific concept. It's the grand process of transforming a barren, alien world into a livable environment for life as we know it. Imagine being able to walk on the surface of Mars without a spacesuit, breathing in the Martian air. That's the ultimate goal of terraforming. This process involves a number of large-scale engineering projects, each aimed at altering key aspects of a planet's makeup. Firstly, the atmosphere. This needs to be thickened and its composition altered to support life. Next, we have temperature, too cold or too hot, and life as we know it can't survive. We'd need to find ways to warm or cool a planet to just the right degree. Then there's surface topography, shaping the land to support bodies of water and various ecosystems. Lastly, we'd need to kickstart an ecology, introducing life forms that can thrive and create a balanced, self-sustaining biosphere. So how does one go about terraforming a planet like Mars? The first step in terraforming Mars is building an atmosphere. Now you may wonder, why is an atmosphere so vital? An atmosphere is like a cozy blanket around a planet, keeping it warm and shielding it from cosmic radiation. It's also the air we breathe, and it's what makes the sky blue on a sunny day. Mars does have an atmosphere, but it's not exactly inviting. It's thin, about 100 times less dense than Earth's. It's also made up mostly of carbon dioxide, about 95%. The rest is a mix of nitrogen and argon, with trace amounts of oxygen and water. So it's not something you'd want to breathe in. So how do we go about changing this? Well, there are a few possibilities. One of them is redirecting comets. Yes, you heard that right, comets. Comets are made up of water ice, dust, and various gases including carbon dioxide, methane, and ammonia. If we could somehow redirect a comet to crash into Mars, it could release these gases into the atmosphere. A few hundred comets might just do the trick. Another method could be using greenhouse gases. We're all too familiar with how greenhouse gases like carbon dioxide trap heat and warm up our planet. On Mars, we could use this to our advantage. By releasing greenhouse gases into the Martian atmosphere, we could trap more heat and make the planet warmer. This would also help to thicken the atmosphere. But these are just ideas, and they come with their own set of challenges. For instance, redirecting a comet is not exactly a walk in the park. And if we're going to release greenhouse gases, we'd need a lot of them, which raises the question, where are we going to get them? Despite these challenges, the dream of terraforming Mars is one that continues to inspire us. It's a monumental task, one that would take centuries, if not millennia. But as they say, every journey begins with a single step. Once we have an atmosphere, the next step is to warm up the planet. Mars needs to be warmed up, and this is where greenhouse gases come into play. To warm up the red planet, we need to take a lesson from our own home, Earth. Here we have a natural blanket of gases in our atmosphere that traps heat and keeps our planet at a hospitable temperature. This blanket is made up of greenhouse gases like carbon dioxide, methane, and water vapor. They work by letting sunlight in, but preventing some of the heat from escaping back into space. Now, imagine applying this concept to Mars. If we could increase the concentration of greenhouse gases in its atmosphere, we could trap more heat and raise the planet's temperature. This would make Mars more suitable for life as we know it. There are several ways we could go about generating these greenhouse gases on Mars. One method could involve the introduction of methane-producing bacteria. These microscopic life forms, known as methanogens, thrive in extreme environments, and they produce methane as a byproduct of their metabolism. By introducing these hardy little organisms to the Martian soil, we could set off a biological chain reaction. As they multiply and thrive, they would release more and more methane into the atmosphere. This methane would then act as a greenhouse gas, trapping heat and raising the planet's temperature. It's important to note, however, that this is just one potential method. There are other options on the table, like manufacturing greenhouse gases right here on Earth and transporting them to Mars. Or we could even try to stimulate natural processes on Mars that would release these gases. But whichever method we choose, the goal remains the same: to create a warm, hospitable atmosphere on Mars. It's a monumental task, no doubt, but one that could open the door to a new era of space exploration and colonization. With a warm atmosphere, the next step is to introduce liquid water. Water is the elixir of life, and Mars needs it to sustain life. In the grand tapestry of existence, water is the thread that weaves life into the fabric of reality. It's an essential ingredient in the cosmic recipe for life as we know it. On Earth, wherever there's water, there's life. From the deepest ocean trenches to the highest mountain peaks, organisms of all shapes and sizes thrive in the presence of this life-giving liquid. So it stands to reason, if we want to create an environment on Mars where life can flourish, we need to introduce liquid water. But how do we accomplish this? Well, remember how we talked about warming up the planet and building up the atmosphere? These steps set the stage for the introduction of liquid water. You see, Mars is home to vast reserves of frozen water, locked away in its polar ice caps and potentially even beneath the surface. By raising the temperature and increasing atmospheric pressure, we could coax this frozen water into a liquid state. This would not only provide a source of water, but also contribute to the warming of the planet through a process called the greenhouse effect. The possibility of underground water reserves on Mars is also a tantalizing prospect. Recent studies suggest that Mars may harbor subterranean lakes of liquid water, a revelation that could change our approach to terraforming. If we can tap into these reserves, we could potentially have an abundant source of water without needing to melt the ice caps. However, this is still an area of active research, and our understanding continues to evolve. So, we've got our atmosphere, we've warmed up the planet, and now we've got our water. It's starting to look a lot like home, isn't it? But we're not done yet. The next step in our journey to transform Mars into a second Earth is possibly the most exciting one. The final step in terraforming is the introduction of life. An audacious endeavor indeed, but one that could redefine our understanding of existence itself. Introducing life to Mars is not as simple as packing up a few plants and animals and setting them loose on the red planet. No, this will require a deft blend of biology, technology, and perhaps a dash of cosmic luck. One possible approach to seeding Mars with life could be through the concept of panspermia. This is the hypothesis that life exists throughout the universe and is distributed by space dust, meteoroids, asteroids, and planetoids. In theory, we could deliberately engineer a form of directed panspermia, sending hardy microorganisms to Mars that could survive the journey and begin to proliferate once there. These could be extremophiles, organisms that thrive in extreme conditions, or perhaps even genetically modified organisms designed specifically to flourish in Martian conditions. However, as with any grand endeavor, there are potential challenges to consider. Firstly, the organisms we send must be able to survive not just the journey, but also the harsh conditions of Mars. They would need to withstand high levels of radiation, freezing temperatures, and a thin atmosphere, among other challenges. Secondly, we must consider the ethical implications. Is it right for us to play God, to engineer life and introduce it to an alien world? What if our efforts unintentionally harm potential existing life on Mars, or disrupt the planet's natural evolution? These are not questions with easy answers, but they are ones we must grapple with as we stride forward into this brave new frontier. To introduce life to Mars, to make it a living, breathing planet, is a dream that fires the imagination. It's a task that draws upon our deepest wells of creativity and our most sophisticated technology. And yet, it is a dream that is tantalizingly within our reach. With these steps, Mars could potentially become a second home for life as we know it. The journey to terraforming Mars is filled with challenges and unknowns. We must first construct an atmosphere, then heat the planet to a hospitable temperature. Next, we introduce the fundamental component of life, liquid water. Finally, the introduction of life itself. Each stage is fraught with uncertainties, a testament to the audacious nature of this endeavour. But with the pace of our technological advancements, who knows? The dream of living on Mars may not be as far-fetched as it seems.